Okay, this video is going to give you something that's just a little trick, something that allows us to use complementary angles. Because it deals with complementary angles, it is called cofunction. That's the same thing there. And complementary angles are two angles whose sum is 90 degrees or pi over 2 radians, right? Pi over 2 is 90. So that's why you see here the pi over 2. This could be 90 degrees, 90 degrees, 90 degrees. Basically what this is saying is if two angles add up to 90, or pi over 2, the sine of one of them is the cosine of the other. The tangent of one is the cotangent of the other. The secant of one is the cosecant of the other. We have seen this in the unit circle and with the 30 degrees and 60 degrees. Okay, that's probably the easiest one to show this with, or in radians, that's what, pi over 6 and pi over 3. The sine of 30 degrees is 1/2, and the cosine of 30 degrees is √3/2. Well, guess what the sine of 60 is? √3/2, and the cosine of 60 is 1/2. So this is what this is telling us here. The sine of one angle is the cosine of its complement. The cosine of one angle is the sine of its complement, and it works with all the other cofunctions, tangent and cotangent, secant and cosecant. So you see those cos there to help you know which ones go together. All right, so here's a couple of things we're going to do with this. Nothing too bad. If we want, they say to rewrite this function in terms of its cofunction. So the sine of 34 degrees is the cosine of what? So we would do 90 minus 34, which is 56. So the sine of 34 degrees is the cosine of 56 degrees. Those two angles add up to 90 degrees, so the sine of one of them is the cosine of the other. The cosecant of 2 pi over 5 is going to be the secant of something. And the way we find the something, we're going to say pi over 2 minus 2 pi over 5. So what do we get? 10 pi over 2? No, that's not right. 5 pi over... Goodness, I can't do fractions. I'm trying to do too much without thinking. My common denominator is 10, not 5. Okay, so it's 5 pi over 10, there we go, minus 4 pi over 10, right? Yeah, there we go. Okay, so the complement to 2 pi over 5 is what? 5 pi minus 4 pi, pi over 10. So since these two angles add up, I hit eraser there instead of... Since these two angles, I've messed this problem up royally, add up to pi over 2, the cosecant of one of them is the same as the secant of the other. Okay? All right, let's simplify these things. The sine of 10 degrees over the cosine of 80. They don't want us to use a calculator here. What they want us to realize is 80 plus 10 is 90. So these are complementary angles. So the sine of 10 is actually the same thing as the cosine of 80. And the cosine of 80 over the cosine of 80 is 1. Right? Okay. Now, sine squared pi over 6 and sine squared of pi over 3. Pi over 6 and pi over 3, that's 30 degrees and 60 degrees, right? These are complementary angles. So the sine squared of pi over 6 is actually the same thing as the cosine squared of pi over 3. So we're going to write these with the same angle. And then the sine squared of an angle plus the cosine squared of the angle is 1. right? So we did it without a calculator. We just used the fact that the two angles added up to 90 degrees or pi over 2.